All right, this is problem number 76 from chapter 4 of the Halliday and Resnick textbook. We worked on this yesterday in class, and I got a little turned around on it, so I figured I should put up a proper solution here, so I apologize for that. So here's the deal. We got a plane that can fly at an airspeed of 500 kilometers an hour. So the velocity of the air, So airspeed, remember, that represents the velocity of the plane relative to the air. It's the velocity that the plane would have if there wasn't any wind, okay? And so that's 500 kilometers an hour. All right? It says that the pilot sets out for a destination that's 800 kilometers due north. So our goal is we want our displacement, our change in position of the plane relative to the ground, to be 800 kilometers due north, right? And then later on it tells us that's going to take 2 hours, right? So if you divide by 2 hours, that gives us the average velocity of the plane. If we assume it's flying at a constant velocity, then we find that the velocity of the plane relative to the ground is 400 kilometers an hour, again, due north, right? All right, and so the question is, what's the velocity of the wind? What's the velocity of the air relative to the ground? Okay, notice that's not airspeed. The airspeed is the velocity of the plane relative to the air. All right, we're looking for the velocity of the air relative to the ground. Okay, so how do all of these things fit together? So we've got 3 different velocities here, right? So you can write it out in a couple of ways, but the way that jumps out at me is this. The velocity of the plane relative to the ground is going to be equal to the velocity of the plane relative to the air plus the velocity of the air relative to the ground, right? So we need to draw a vector diagram that represents that. All right, we already know what we want the velocity of the plane relative to the ground to be. So the velocity of the plane relative to the ground is supposed to be 400 kilometers an hour due north, right? Now, the problem tells us that in order for this to happen, the plane has to head in a direction that's 20 degrees east of north. So that's this 500 kilometers an hour. So here's 20 degrees east of north, and the idea is the velocity that the plane would have to fly at if there wasn't any wind would be at 20 degrees east of north, and it can do that at 500 kilometers an hour. Right? Now, you wouldn't know without doing the math that this point up here is sort of farther north than this point. When you do the calculations, that it shows that. So, I guess don't get too bogged down with sort of how far you draw this arrow up here. Okay? So here's the velocity of the plane relative to the air. That's this guy. So I need to do tip to tail the velocity of the air relative to the ground. And that gives me this guy, right? Okay, so that's my setup. All right, so there's our setup. So at this point, now it's just vector addition. All right, so let's do this. Here's what we know. We know that the velocity of the plane relative to the air plus the velocity of the air relative to the ground is equal to the velocity of the plane relative to the ground, right? So the velocity of the plane relative to the air. So I need to do a little bit of trig here, right? So I've got this triangle, 500 kilometers per hour. So here's the y component of that. Here's the x component of that. I'm going to get a little sloppy here. Let's call this v. And here's my 20 degrees, right? So I'm just going to use, sine and cosine and find the components. And if you do that, you find that the velocity of the plane relative to the air is 171 I plus 470 j, and this is all in kilometers per hour. Okay. Now, the velocity of the air relative to the ground, we don't know. So let's call this the velocity of the air relative to the ground, x. Okay. So that's our I component, plus the velocity of the air relative to the ground, y component, j, right? So this all has to add up to the velocity of the plane relative to the ground. Well, the x component of the velocity of the plane relative to the ground is 0, right? Plus, the y component is 400, right? Okay, so solve for your unknowns. So solve for your unknowns, So basically I'm going to say, well, 171 plus what is 0? So my VAGX has got to be negative 171, right? Otherwise it doesn't add up. Okay, and then similarly, look at your Y components. I've got to have 470 plus something equals 400. So that's got to be what? Negative 70. All right, so there's that. So now these are both in kilometers per hour. All right, and so let's see, let's buy ourselves a little bit of room. So now we can draw this guy, right? Let's see, so we know that our X component, the AGX component is negative 171 kilometers an hour. VAG in the Y direction is negative 70 kilometers an hour. And we're looking for the velocity of the air relative to the ground. All right, so you just do your Pythagorean theorem, you get 185 kilometers an hour. Find your angle using a little bit of trig, and you get 22.3 degrees south of west. All right, there you go. I think the most confusing thing about this is sort of where this angle goes. So, I don't know. Anyway, there you go.